In this section, we're still talking about functions. This is functions part 2. The goals in this section, we want to evaluate functions that are defined as formulas. So in other words, given an input, what's the output? Also, later on, we'll talk about given an output, what's the input? Okay, so that's goal number 1. Goal number 2, we want to find the domain and range of functions that are defined as formulas. And goal number 3, we want to solve applications of functions. So let's get started by talking about function notation and how to use it when functions are defined using formulas. And function notation, it's like all jargon. At first it seems weird and scary, but it's actually useful, and once you get used to it, it's not that weird and it's not that scary. So function notation, okay, y equals f parentheses x. What do we say when we see that symbolism? First of all, it doesn't mean f times x on the right side. Okay? When we see this, we say or think y equals f of x. So if you see y equals f parentheses x, think y equals f of x. Okay, so what does this notation mean? It's really a rearrangement of the ordered pair notation. And the reason we use f of x in place of y is it's a quick notation for telling you what to input. So when you see y equals f of x, really what we use it for is I'll change the x to something. X is a generic representation of the input, right? It's the independent variable that represents the input. I will change x to something particular, like f of 2. And what it does is it tells you what to substitute in for x in your formula. Or it tells you to look at your listing of ordered pairs and find the y value that goes with a certain input value. So it's a shorthand way to denote the input and the output. Now all that's very abstract, so let me just show you an example and you'll see it's not that weird. Take a look at the function defined using the formula f of x equals x squared minus 3. Now by the way, this isn't as strange as it looks. You can always replace f of x with y, so you could rewrite this. It's the same thing as saying y equals x squared minus 3. So don't let the jargon scare you, okay? F of x is a replacement for y. It's the same thing. Now, what's the use of the function notation? Well, if we want to evaluate something quickly, we can denote what we're plugging in by, instead of using x inside the parentheses, use whatever number you want to plug in. So like in part A, if you're asked to find or evaluate f of 2, really it's telling you, hey, give me the output for the input of 2. It's just saying plug in 2 for x. Oh, substitute 2 in for x, we know how to do that. So we take x squared minus 3, the formula, and we replace wherever we see an x, we replace it with 2. We substitute in 2. That's not so scary, is it? Okay, so what I like to do, it's a good habit to get into, is the letter, if it's x, the independent variable, the letter that you're replacing with a number, put a set of parentheses where it used to be. So instead of x squared minus 3, parentheses squared minus 3. And in that set of parentheses, your new input is 2. Does that make sense? So f of 2, instead of f of x being x squared minus 3, f of 2 is 2 squared minus 3. You're substituting 2 in for x. And then order of operations, do the exponent first and then subtract 3. What do you get? 4 minus 3 is 1. This is the same thing as saying the ordered pair, same as saying the ordered pair two, 1 is on the graph of the function that we called f, okay? F is also the name of the function. In other words, you can look at this notation and say, hey, the input is 2, and for an input of 2, you get an output of 1. And if you want to change that to an ordered pair, it's the ordered pair 2, 1. So different notation for stuff you're already kind of familiar with, isn't it? You've substituted numbers into equations lots of times. Okay, what if we want to find f of negative 4? So I'll squeeze that in right here. Do you guys want to try this one? Try this one in your notes, you guys, just to make sure that you're staying awake. I know listening to me is exciting, but you can only listen for so long, right? It's f of negative 4, actually. So find f of negative 4. So just run it through the formula. Tell me what you get. Don't shout it out. Give everybody a chance to do it. Oh, you couldn't resist. I heard it. Somebody said 13. All right. So any question? Can I just write it down? Any questions? Do you need to see me do it? You just plugged in negative 4 here. What happens in the negative? Yeah, it's squared out, right? So 16 minus 3 is 13. So what's the ordered pair that goes with it? No. Negative 4, 13. The input's always in the parentheses. So the first coordinate is negative 4. The second coordinate is 13. So negative 4, 13 is on the graph of that equation. F of x equals x squared minus 3. What do you think it means in part B? What do you think it means to take f of a? Well, good guess. No, you don't know what a means. You're not given a context here, right? But the function notation always means the same thing. The input now, instead of being x, the input is a. So you just replace x with a in the formula, if you're given a formula. So all you can do is replace this x with a and get a squared minus 3. That's it. There's nothing else to do because you don't know what a is. Okay, but can you see that the function notation is doing the same thing here? The input is now a, so you replace x with a. Okay. Now, do we have to use f every time to denote a function, or x and y? Certainly not. So don't depend on those letters, right? If you see something like g of m equals negative 2m plus 5, this guy in parentheses is your input. M is your input. And by the way, you could always replace g of m with y. So it is the same as, well, if you don't want to use y, maybe that doesn't make so much sense here. What could you use instead? Maybe n and m, right? M, the input, and the output. So you could, if you want to say n equals g of m, you could use y. There's no reason why you couldn't. But let's say n is equal to g of m, then it's understood then that you could replace g of m with n and get n equals negative 2m plus 5. Y would work also. And it's alphabetical order if you're not told otherwise. So the letter that comes first in the alphabet would be the input if you're not told otherwise. That can change. For instance, if an input is, if one of your variables is time is usually always the input variable in any application, okay, no matter what the other letter is. But if you don't know, it's alphabetical order. The letter that comes first in the alphabet is the input. The letter that comes last is the output. Okay, so we have g of m equals negative 2m plus 5. What's g of a in this case? What are you going to do? What are you going to do with that m right there? Just make it a. So negative 2a plus 5. It's virtually the same as the last example, right? You just make the input whatever it has inside those parentheses. Ooh, what about g of a plus 2? Okay, so here's a good opportunity. If you're ever confused about what the input should look like or what the formula should look like, rewrite the formula with a set of parentheses where the input variable it was. So instead of negative 2m plus 5, make it negative 2 parentheses. Notice I made them wide parentheses, plus 5. And inside the parentheses, the new input, instead of m, the new input is the whole quantity, a plus 2. It's consistent. We're doing the same exact thing we did in the last example, the last 3 examples. Could you do something to simplify that maybe? Could you multiply that out? What would you get? Negative 2a minus, don't forget the minus, 4 plus 5 on the outside though, right? So all we did was get rid of the parentheses. We still need to combine like terms. So what do we get? Negative 2a plus 1. Okay, so for an input of a plus 2, we get an output of negative 2a plus 1.